Hello everyone, in this lecture we will discuss about CMOS fabrication using PWEL process. In PWEL process, we have to select the base material, that is nothing but N-type silicon substrate. As we already know that the well and the substrates should be complement with respect to each other. So here our base material or starting material is N-type silicon substrate. And the next step is we have to deposit thick silicon dioxide all over the surface in order to protect it from the contamination, which is known as thermal oxidation process. And then we will move on to the next step, that is nothing but photolithography. So where we are going to deposit light sensitive material which is known as photoresist. So it will allow the remaining wafer to the exposure of UV radiation. So where we are going to deposit the active regions for formation of various terminals like gate, source and drain. So next we will move on to the masking. So here immediately after depositing the photoresist, so the next thing we have to do is we have to prepare a mask, so such that the selective regions on the substrate is exposed to the ultraviolet radiation. So wherever we have exposed it to UV radiation, the respective region is stripped off in order to form the PWEL inside the N-type substrate. Next we will move on to the next step, that is nothing but the removal of unexposed photoresist. So before the removal of the exposed photoresist, now we will remove the extra unwanted photoresist that is present on the substrate. So here with the help of a few chemicals such as trichloroethylene, we will remove the excess amount of photoresist from the substrate surface. And then we will move on to the etching process. So that means here the wafer which is exposed to the ultraviolet radiation is immersed in the chemicals such as hydrofluoric acid, and then we will remove the photoresist as well as the oxide which is present where we need to form the PWEL. So next we will remove the unwanted photoresist layer as well as the silicon dioxide layer from the substrate, and then we will move on to the formation of PWEL. So here you could see in the base material which is nothing but N-type substrate, so we are going to keep PWEL so by the process of diffusion. That means we will heat this substrate at higher temperatures, and then we will allow the impurities or dopants which contains P-type semiconductor material. So here you could see the formation of PWEL which is of the depth of 4 to 5 micrometer size. And then we will move on to the removal of excess silicon dioxide layer which is present on the wafer surface. Next we will concentrate on the formation of polysilicon gate. So in order to form gate, we need to deposit polysilicon all over the surface. So here before the formation of source and drain terminals, it is necessary to form the gate terminal. Why? Because in order to avoid the unwanted capacitance which could harm the circuit, so we will form the gate terminal first, and then we will concentrate on formation of the source and drain terminals. So here you could see the formation of gate terminals for PMOS as well as NMOS devices. So next we will move on to the once more oxidation process, where the other regions are covered with oxide layer in order to proceed with the further steps such as diffusion of N-type as well as P-type terminals, and then we will move on to the metallization procedure. So here we require additional protection, so that is why this oxidation step is compulsory. So once more we will carry out masking, and then we will move on to the diffusion. That means once more we are going to deposit the photoresist layer, and then we will prepare the mask, so where we are going to expose this surface to the ultraviolet radiation. So such that the terminals, the required terminals such as drains and source terminals of respective N device and P devices are formed. So and then we will move on. Next, we will move on to the next step, that is nothing but ion implantation. What is this ion implantation? That means formation of ions such as P plus ions inside the N substrate. So here we are concentrating on the formation of source and drain terminals for the PMOS device. So here for that purpose we require a P plus mask. So initially the substrate is exposed to ultraviolet radiation through a mask. So where the regions which are required for P device are selectively exposed to the UV radiation with the help of a P plus mask. So here we will form drain and source terminals of the PMOS transistor. Next, we will concentrate on the N-type diffusion, that means formation of source and drain terminals for the N device. So before doing that, we need to remove the excess oxide layer that was present on the wafer substrate. So once more, the processes of photolithography and then masking are repeated. So in order to create the regions, so where we need to allow N-type diffusion gas. So here we need to form the terminals of N device such as N-type source and N-type drain. So next we are going to form a thick field oxide. Before we are going to process the next steps such as metallization. So we require an additional protection. For that purpose we are going to lay all over the surface the thick field oxide once more as a protective layer. So and then we will carry out the metallization process. So where we are going to deposit the aluminum metal all over the wafer substrate in order to provide the interconnections. So and then we will remove the unwanted metal regions in order to give the bonding pads to the external regions. So here you could see the overall structure of CMOS transistor by using P-well process. So here we have taken the P-type substrate and then we have inserted the P-well. So inside the P-well, what device we have performed? We have formed the N-type device, and then in the substrate we have formed the P-type device, and then all these devices are connected with the interconnections with the help of the metal layers such as aluminum. So here you could see the substrate connections also. So the P device requires the N-type substrate connections, as well as the N device requires P-type substrate connections. So and here you could see all the gate terminals are connected together in order to provide the input, and one of the sources and drain terminals are connected together in order to get the output out of the device. So thank you so much.